Okay, and here's Isopy.
Cool.
Right. People, they're ready.
Okay. Hi, I'm Shanice from Columbia University.
I'm Laura.
I'm Tongya, a visiting student at Columbia University.
I'm Kexin. I'm from the University of Miami.
In this week, we made a package called Isopy. We did some tests, and we can install the package in our local computer.
So the reason we made this package, which we don't think exists, but maybe somebody's going to tell us that it does exist, is is because a bunch of us actually independently were having a problem with doing things like interpolating different variables to isopycnals, or just finding the depth of some isopycnal in like a gridded data set. So that's why we wrote this package, because we wanted to kind of generalize that process.
Yeah, so we built a package, and there are 3 functions. You can employ them to calculate the isopycnal and isosum surfaces and compute the variables.
Yeah, so this week we learned how to build a package and what goes along with it. So we learned that it needs like a licensing file. It needs a README to explain to the users what it is and how it could benefit them. And we need a file called a knitpy that's empty, but it still works. And an important file, we need an environment YAML file to specify the packages that we use to make our own code work. Yeah, and obviously we need our own package. So here's a little like notebook demoing our package.
Okay. So as we know, physical oceanographers care about density, temperature, and salinity. So our first function is called compute ISO. The input is your Argo data or any other data. Is a 3-dimensional with depth, longitude and latitude, and a specific value of density or temperature. Then you can compute the depth of the isopycnal or isothermal surfaces. Here is the map of the global 25 sigma surface. The light yellow is the deep area, and the dark purple is the shallow area. We also try to use the HV plot with what we learned this week. And when you stop, when you stop at the location, it will show the value.
Well, it should show the value.
It should show the value. Yeah.
For some reason, after it stays open for a while, it doesn't pop up. Well then, just believe us that it just shows when you hover over the map, it shows you lat, lon, and the depth.
Oh, here we go. Yeah. This is the depth of 25 sigma, and you can also zoom in to have detail. So let's go to the second function.
So the second function that we made is called isoval. So it would compute some variable along a surface of constant density. And so we kept with that 25 sigma surface, and then we calculated the salinity and temperature. And we made some plots in Cartopy. This is the first plot. So we've got temperature along that surface with the light colors. Yellows is warm temperature, and then the darker purples are cooler temperatures. And then we've also got salinity here again, with dark orange is really salty, and then yellow is fresher.
Okay, the third function is called ISO average, which is used for calculating the depth average available above some isopycnal layer. If we reduce ocean to some several layers, such as reduced surface model, people may care about the average of the ocean stage between some isopycnal surfaces. That's why we built this function. And we did some tests using Argo temperature. But this function can also use to calculate salinity and velocity from any model output. But for now, this function can only calculate the depth average between sea surface and some isopycnal layer. In the future, we will extend this calculation to any isopycnal layers.
Yeah.
So that brings us to like some concerns that we have to make this package truly fair. The acronym we learned this morning: definable, accessible, interoperable, and reusable. Specifically, the last 2 points, because we did only test one data set, the Argo data set. So to test whether this code is brittle or fortified, we would obviously run some more or try out more data sets like Echo or data sets that you guys have. And then also on your other machines, we did try it on one of our local machines and it did work. So there's that. And then the function is slow. We tried to lower the computation cost and time with Dask, but we ran into some problems and we just couldn't figure out how to parallelize the work within the loops. So there's that we have to work on. But we can still publish it. It works.
Yes.
Yeah.
Yes.
I can't be asking all the questions. Come on, help me. All right. Sorry, I have to. Go back to the loops where you do the ISO application. Show that first. And yes, there are 2 other numbers that are right there. Yeah, go to the actual loop.
For the first function,
Yes.
it's a bit long.
That's fine, no problem.
Okay.
That's probably quite slow, right?
Yes, it is.
And how are you handling the bottom and the top in case you have to extrapolate?
You mean like if we pick something where the next value is like above? Yeah, we didn't handle that.
Yeah.
So the 2 libraries that exist, one's called Python Stratify that handles that. The other one doesn't handle that, but it's fast because it's a synchronized version of that loop. Pretty much the same thing. Don't feel bad for doing something that exists. Inventing the wheel is good. You will come up. Like ours used to be the only software to do NetCDF model. X-ray, the author of X-ray tried to contribute to ours, wasn't successful, created X-ray, so now we have a better tool thanks to that. You actually went forward and create more derived functions that are very useful. So as an exercise, I'd love for you to go to these other 2 libraries, see what they're doing, because none of them are complete. Like these 3 libraries do something similar, but they all add a new thing. And maybe collaborate to merge into one that actually is very fast, handle extrapolations, and have all these nice extras that you added.
What was the second one?
One's called C ISO because it's cycling ISO, and the other one's called Python Stratify. Okay. And folks, they create an actual package that is installable. That's all.
That was going to be my question. Like when you showed us a notebook, but you.
Oh, okay. Yes. Yeah. Sure. Oh, yeah. We can go back to that. So we didn't push it to like I think it was PyPy or Conda yet. So the way you would import it would be in like some develop syntax mode. So you can still import it. It would just have to be a different syntax than if you were to regularly import a module.
I happened to be having this conversation earlier that you can, once you put the effort to turn it into a Python package, you can finish stuff from GitHub.
Yep.
You can do this
Directly.
Yep.
But if you want to put that on PyPI and later on Conda, let's coordinate, and I can help you make that happen.
Yeah.
Right. Any other question?